Hey guys, welcome to this new tutorial of ice. Today we're gonna do a quick sketch of some particles, and we'll see how ice is really good for working with particles. So let's get started with that. The first thing we're gonna do is just create a few grid planes. So we're gonna create this polygon mesh grid, right? So let's go ahead and just scale this guy just roughly around the size of our space here, and we're gonna go into hidden line removal mode, right? And we're also gonna create another one that is gonna be our emitter. So one of the ways in which we could create these particles right away is like having selected this grid, right? We could go into particles here in the ice tab and create basic emission, and you'll see that automatically there's kind of series, like a nice tree gets created, and we could basically just emit particles from the surface. So that kind of gets set up for us. So let's go ahead and just use maybe 10,000 frames just to, and you'll see that ice is quite powerful in terms of like the amount of particles it can handle, and in a way we're kind of just very quickly producing this emission. What we want to start producing here is just a little bit of behavior and also a simulation that it's kind of optimized in some degree, right? So the first thing we're going to do is just like bounce on surface. So there's a command here, bounce on surface, right? And we can expand these nodes just to understand what each one of these does, right? And we're going to leave this guy over here. So we have bounce on surface, and we have this second grid. We could already name them actually, to just say this is floor, and this is going to be the emitter. Oops. Right? So let's drag the floor in, and we can just connect it to bounce surface, and we will connect this one to the execute in the simulation node, right here. Right, so that gets activated, and we'll see what these guys are, right? So let's see now. We have these particles flying around, and you see that they bounce, and that works pretty well, right? The problem is that we don't have any gravity or anything really, so let's also add some gravity, right? Gravity force. The gravity force is just a vector. If we open it up, it's just -9. We could reduce that if we want. We could say -5, right? And we also would need add force node, which is, in a way, it's going to pick a vector and it's going to pass it on to our force simulation node, right? Which is an execute node. So basically, what we have here, this brown one, is the emit from geometry node, which is actually saying how these particles are getting emitted from this surface. So we're actually getting this emitter, and this surface becomes the emitter of this surface. That's been done for us. The simulation is how that simulation gets works. We could use states. It's something that we're going to see later, like a state machine for behaviors of particles. Right now we're just using emitters, forces, and the execution for additional elements that we want to calculate, like the bounces, and the simulation of particles gets activated after that, right? So we're kind of calculating all these elements together, and we get the result. Yeah, this is just the simulation particles node. And let's see if the gravity force is actually working right now. So you see that now we're getting gravity. So they're kind of bouncing down, and that works pretty well. The problem is that these particles never die, right? So we have quite a long timeline here, and you see that we are starting to create a big giant amount of particles that it's eventually going to slow down the system quite a bit, and yeah, it's probably going to crash in some point. Well, perhaps not, but we should actually try to solve this and deal with a fewer number of particles, the ones that we need for our scene. So what we're going to do here is also make an if statement, as we've done before. So we're going to say if smaller, so we're going to get the data of the particles. So self dot point position, right? So we're getting the position of the particle, which is the point position as well, and we're going to convert this data. We're going to say vectors 3D, or vectors to 3D vector to scalar. That's the one we want, right? So we're going to connect the position of the points. We're going to decompose it as a x, y, z values, and we're going to say that the y-axis, if it's smaller than 0, so if the y is smaller than 0, we could just be explicit about that by using a scalar, and perhaps it could become a slider for us. So if it's smaller than 0, that's the condition. What do? We're going to delete the particle. So here. So we're going to delete the particle if that happens, right? And we are going to just, we could actually plug this one directly here. So you see that we are adding a part of the structure now that would actually kill particles. We're going to keep with a decent number of particles here, right? Let's see if that works. So you see that we have 0, our particles are bouncing around, and eventually when they get out of the loop, you see that they're reaching 0 and they're disappearing. We could use less than 0, we could use -5, and you see that particles are able to go a bit lower before they disappear, so we can actually have a simulation like that. So let's do how to do some changes. First of all, I want to deal that the bounce, it's not so, I want to do some drag. So the bounce factor, I'm going to put 0.8 per, maybe something like that. So now every time it bounces, there's some force lost in the process, right? So the bounces are getting smaller and smaller, and you see that this is a bit more realistic in the sense of how, you know, like the particles bounce over a surface, right? So that's where you would actually deal with that, in the bounce on surface node. And here you could actually come to the emit node, and here's where you have they're emitting from the surface, they're emitting number of particles per second. So you could say total number of particles. If you say total number of particles and repeat this operation, you're just gonna get a bunch of them, and you know, you're gonna get that. So if you want a continuous flow, you could say less, right? Like 100, and you have a more controlled number of particles. You can also control here the mass of the particle, the size of the particle. For instance, we could say 2. We're not seeing that because it's a point. But if we switch the shape of the particle to a sphere, and we control the size of them, we could see that we can have better control over our simulation, right? And if we start from scratch, because everything that we do, it's being altered in real time, so if we start from scratch again, you'll see that all the particles are having the same size. And here, this is the strength in which that the particles are having once they kind of get released. So you see that we can increase the speed of the particles, and they kind of come stronger, or they come really slow, and you can play with that interactively, just throwing some particles at different speeds. Obviously, all these values you could actually link operators, just like, let's say, a random operator or any sort of operator that will deal with this, right? So let's look at some The viewport of Softimage is pretty good as well. So here we have a series of particles. So we're gonna just turn on a few things, like in the display options here, display options, we could actually enable fog, right? And we could make it white or black to start kind of sensing a bit better the depth of the scene, and that seems to work pretty well if you want to just do a quick kind of a preview render of your scene. That could work. Headlight would actually maintain the direction of the light to in relation to the camera, so it's something that is useful also for getting kind of clean results. I kind of like the hidden line removal mode. It's a bit kind of cartoony, but and with this kind of fog going on, it seems that it looks pretty good. So that's gonna be it for this introduction to particles, and we're gonna go in depth in further videos. See you guys soon.